Good day, everyone. Um, my name is Vincent Tumbiga, BS in Electrical Engineering.
And my name is Yves Carampatan, also a BS in Electrical Engineering.
We present to you our research topic entitled The Impacts of Hazardous Materials in Production of Solar Energy Charging Stations or Panels on the Environment.
So, the sun is a huge source of energy which has only recently been tapped into. In one of the news published by Green Match, the sun provides immense resources which can generate clean, non-polluting, and sustainable electricity, thus resulting in no global warming emissions. In recent years, it was discovered that solar energy can be collected and stored to be used in a global scale with the purpose of eventually replacing the conventional sources of energy.
As the world is turning its focus to cleaner power, solar energy has seen a significant rise in importance. Anent this, a report from National Geographic 2014 stated that manufacturing of solar charging stations or panels can have environmental downsides. Therefore, in fabrication of solar panels requires caustic chemicals such as sodium hydroxide and hydrofluoric acid, and the processes uses water as well as electricity, the production of which emits greenhouse gases that also creates waste. These problems could undercut solar's ability to fight climate change and reduce environmental toxic.
However, there are potentially negative effects of hazardous materials in the production of solar panels in the environment. One of the environmental impacts associated with the solar panels that should be considered are the use of soil, water, and air resources.
According to a news published by Greenmatch 2021, the construction of solar facilities on vast areas of land imposes clearing and grading, resulting in soil compaction, alteration of drainage channels, and increased erosion. As with the development of any large-scale industrial facility, the construction of solar energy power plants can pose hazards to air quality. Such threats include the release of soil-carried pathogens and release in an increase in air particulate matter, which has the effect of contaminating water reservoirs.
In connection to this, a variety of hazardous compounds are employed in the PV cell production process. Solar energy may have both a direct and indirect positive impact on the environment. The photovoltaic or PV cells that convert sun into power, however, are made using some harmful minerals and chemicals. Some solar thermal devices transmit heat using potential dangerous substances. The environment could be harmed if these materials leak. Right.
Waste minimization is commonly used in the semiconductor industry and is applicable to the PV sector as well. It involves things like reusing rainwater after treatment, switching to less toxic chemicals as much as possible, controlling spills and leaks, reducing vapor losses, and choosing processes that utilize fewer hazardous chemicals, limiting the amount of damaging solvents and acids. These different ways can help reduce the amount of waste generated during the PV manufacturing process.
So for our statement of the problem,
Advanced technologies in electronic circuits are now commonly used, and the need for efficient power supply in the future will increase. Solar energy may be considered a substitute for conventional energy resources because of its renewability nature. However, there is still a need to consider the impacts of hazardous materials, production of solar energy charging stations or panels on the environment.
This study aims to determine the impacts of using solar energy charging stations on the environment. The study is proposed to answer the following research questions. First, what are the impacts of hazardous materials in the production of solar charging stations or panels on the environment in terms of the following: using land for industrial purposes, developing soil, water, and air resources, recycling solar panels. So the second question would be what type of solar powered panels that greatly affects the environment. Third question is what are the right materials used in the manufacturing solar panels that convert sunlight into electricity in Bi-City solar power plant farm. So, in the significance of the study, the results of this study will be beneficial to the people, environment, and the future researcher. So the environment, with this study, we can make some improvements or adjustments on how to recycle the PV solar cells so that it can be environment friendly. To the people, the study will be beneficial to the people because they will be able to know about what are the environmental impacts of hazardous materials in the production of PV solar cells to the environment. And to the future researcher, this study will help to future researcher to acquire source of information about the toxic and hazardous materials and chemicals used in production of PV solar cells to the environment. So for the
This
scope
study,
and limitations.
this study will cover the Baez Monte Solar Energy Farm in Negros Oriental. The respondents from this study are the people of the community living near the solar panels, the people of the community living near the mining site of the materials used for making the solar panels, and the people in the community who live near the production of site of solar panels are also to be considered. The study also aimed to know about the chemicals used to make the materials and
So,
what is the process on obtaining these chemicals and materials. These materials can be hazardous if not disposed or recycled properly.
so for the theoretical framework, this study is based on the theory that certain materials are used to make solar charging panels or stations that harm the environment. The physical phenomenon responsible for manufacturing solar charging stations or panels are thin film photovoltaic cells. It was originally developed in 1970 by the researchers of the Institute of Energy Conversion at the University of Delaware, USA. According to the photovoltaic cells manufacturing process includes a number of hazardous materials, most of which are used to clean and purify the semiconductor surface. These chemicals, similar to those used in the general semiconductor industry, include hydrochloric acid, sulfuric acid, nitric acid, hydrogen fluoride, trichloroethane, and acetone.
Thin film PV cells are typically made of thin layers of semiconductor materials, for instance, cadmium or zinc sulfide, glass, and a contact material. The materials used in the design of thin film PV cells include polycrystalline silicon, amorphous silicon, and semiconductor compounds. Semiconductor compounds include cadmium sulfide, cadmium telluride, copper sulfide, and copper indium diselenide. In Figure 1 are shown there are shown typical traditional structures of amorphous silicon, cadmium telluride, and copper indium gallium arsenide. These are thin film solar cells.
So for the conceptual framework, this study is anchored on the concept that the sun provides a tremendous resource for generating clean and sustainable electricity without toxic pollution or global warming emissions. The potential environmental impacts associated with solar power, land use and habitat loss, water use, and the use of hazardous materials in manufacturing can vary greatly depending on the technology, which includes two broad categories: photovoltaic, solar cells, or concentrating solar thermal plants.
To produce thin film PV devices, a variety of chemicals and materials is used. The types of and quantities of chemicals used will depend on the type of the technology and type of cell being produced. One can find also some variability in the use of chemicals for producing the same type of photovoltaic solar cells by different PV manufacturers. This means that each manufacturer has its own recipe to produce a type of solar cell. This gives a general list, but non-exhaustive, of chemicals and materials used in the manufacturing of thin film PV cells.
The manufacturing of PV devices includes some chemicals which can be toxic or harmful to the humankind. Potential for health concern is not only depend on the material harmful characteristic, but also on certain conditions which must be taken into account. So for our research methodology, the design and layout in the affected areas of hazardous materials in the production of solar charging stations or panels in a Bai City, Tamiso solar power plant farm was done in a very systematic way as shown in the figure 3 that will be shown in the next slide. This was the very concept followed by the researchers to achieve the best plan to optimize the potential areas affected by the impacts of hazardous in the production of solar charging station. The parameters that were tabulated include the name of the site and the areas affected by the hazardous materials in the production of the solar panels. The important data considered was the effect of hazardous materials of all the meters of the Bai City, Tamiso solar power plant farm.
Figure 3 shown a flowchart of the research design.
So the development of relevant and cost-effective methods for recycling and solar charging stations or panels in a Bai City, Tamiso solar power plant farm, and the possible hazardous materials used in the production of solar charging station panels was determined.
The release of chemicals in form of vapors or spills from the PV industry constitute the real hazard not just the environment but also to the public health. A variety of treatment methods or ways have been developed to minimize waste produced by PV industries. These methods include waste minimization and recycling of PV modules. These different ways to operate can help reduce the amount of waste generated during the PV manufacturing process. PV panels will come to an end about 30 to 40 years, so it is needed to put on some recycling ideas to prevent harmful effects of PV solar cells on the environment. The concept of this approach is to recycle the toxic materials from the PV solar cells and turn it into a product that is no longer toxic and to reduce the potential release of waste or toxic spills into the environment and enhance the amount of new resources.
In addition, developing relevant and cost-effective methods for recycling PV modules is the scarcity of some of the exotic elements used in PV industry, considering that the thin film PV technology is still growing. Some of the elements and chemicals like germanium, indium, and tellurium are decreasing as it is needed to develop more feasible ways to recycle PV solar cell materials. So that's all.
That is all.
That's for
Thank
all
you.
for our research. Thank you.